Hi folks, Brian Benz here, Cloud Advocate at Microsoft, welcoming you to another JDConf 2024 on-demand session. I'm very pleased to introduce to you Emily Jiang, who is a IBM Cloud Native Architect and Advocate, a Java champion, and also a good friend. She's going to be talking about hybrid cloud applications built with pure openness. She's got a great demo to check out, including hybrid cloud, serverless, open liberty, and a few other things. Have a look.
Hello, everybody. I'm Emily Jiang. I'm from IBM. I'm a cloud native architect and also advocate. So I work on open source projects. I work on Jakarta EE, MicroProfile, and Open Liberty. So in today's talk, we're going to talk about hybrid cloud application built with pure openness. So which means you don't need to basically worry about vendor lock-in. So here we go. So first, this is kind of agenda, like hybrid cloud, and then also I introduce you to the open standard, and then like open standard Jakarta EE MicroProfile. They are the kind of the standard to provide basically the APIs. But in order to use it, you will need to use the implementation. And then I will introduce Open Liberty, so it's which give you the implementation so that you can use Jakarta EE and MicroProfile. And then toward the end, I will do a demo. So first, for hybrid cloud. So hybrid cloud is basically public, consists of public cloud and private cloud. So hybrid cloud basically is different from multi-cloud. So for multi-cloud, basically you have a different cloud like Azure Cloud and Amazon AWS and Google Cloud, IBM Cloud, and etc. etc. Hybrid cloud is basically you have both private cloud and public cloud. So it's what is a hybrid cloud application? Basically, this application runs nicely in either private cloud and public cloud without any kind of basically source file changes. Obviously, sometimes you need to change the configuration, etc. But the application, the kind of the binaries and etc., you do not need to make a change. And the last thing is basically what you want to do is you move from one cloud to the other cloud. You have to basically make any changes and have this vendor lock-in. So in this presentation, basically I kind of trying to focus on the hybrid cloud application built with pure openness. So I just adopt all the open standard, and also whatever I discussed here is open source as well. So I mentioned briefly about industry standard APIs, Jakarta EE and MicroProfile. They work together, and they work together really nicely. Yeah, ecosystem to enable you to build modern cloud native applications. So if you have not heard of Jakarta EE is the future of Java EE. So it's enterprise Java, and also is kind of it has better support for cloud native architecture and also native integration with the Kubernetes. And like its API, TCK, and specifications fully in the public domain. So you can get it from the Jakarta.ee website, and also you can access the APIs, JAS, and etc. from Maven Central. So the Jakarta EE community is backed by the industry leaders, including IBM, Oracle, Payara, Tommy 12, Jisoo, and also Microsoft and Red Hat, and together with others. As you can see, it's a huge, basically, it's community effort to move this in the standard forward. For like, if you follow Java EE, Java EE ends Java EE 8, and then further on is the Jakarta EE 8, and then Jakarta EE 9.9, 9.1, and then the latest release Jakarta EE 10. So as you can see, there's about like 30 specifications. You might be familiar with REST. So basically, you create a RESTful microservices, and also the basically phases. You can create basically the front end. And etc. And also the concurrency, WebSocket, and persistent, Jakarta persistent, and etc. And plus with if you are dealing with the traditional application, you might have used EJB. This is all part of the Jakarta EE specifications. And then the platform spec has basically basket, including so many specifications. But if you like focus on the web, basically it's a development. So there's a release called Jakarta E10 Web Profile. It has 22 specifications. As you can see, the useful like specifications such as REST and JSON B, JSON P, and etc. And the CDI is all part of this web profile. And go like on this trend, and Jakarta E10 core profile is even smaller. So it has 7 specifications. This was created basically to cater for the runtime. Basically, is the new runtime, and also would like to do build time compilation support. So this is the Jakarta E10 core profile. Actually, this was created purely for MicroProfile. Later on, I will discuss MicroProfile. And at the moment, Jakarta E11 is basically is in the pipeline, and it will be released this year and in 2024. So watch the space for the Jakarta E11. So Jakarta E11 release, it has many specification updates. And also, one thing I would mention in the Jakarta data is the new specification. If you know, like the Spring data, etc. Jakarta data basically is will adopt some aspect of Spring data, and even know Panache, and also some aspect from that like project as well. Together with many updates such as the CDI and concurrency and etc. So again, so basically this is some update in the Jakarta E11 web profile, and also further down in the core profile. So next is the standard is a MicroProfile. So MicroProfile is a new community. Basically is compared to Jakarta EE. MicroProfile is relatively new. It was created in 2016. Basically, during that time, Java EE was completely stopped. And then it's kind of the microservice moved really fast. We need to have some programming model in Java to help with microservices development. So with that, IBM, Red Hat, Payara, Tommy Tribe, and others created this MicroProfile community. And then in January 2017, it was moved under Eclipse Foundation. Because of this success on MicroProfile, Oracle have decided to donate Java EE to Eclipse Foundation in 2017 as well, to be renamed to be Jakarta EE. So the latest release for MicroProfile is MicroProfile 6.1. Earlier I mentioned the Jakarta E10 core profile. Basically, it was created basically for MicroProfile to consume. So it's basically MicroProfile 6.1 built on top of Jakarta E10 core profile, plus these 8 MicroProfile specifications: MicroProfile telemetry, Open API, REST client, config, fault tolerance, metrics, JWT authentication, and MicroProfile health. Apart from this release, MicroProfile 6.1 release, and on the right-hand side, there's the standalone release. It's not part of the platform. However, this is kind of the some new complementary technologies such as reactive messaging, and then long-running actions, LRA, and GraphQL, and context propagation. And open tracing was previously in the platform, but then we choose MicroProfile telemetry based on the open telemetry, and then open tracing moved out of the platform to become standalone. As you can see here, is just a demonstrate Jakarta E10 core profiles major specifications. So this is a basic timeline to demonstrate how fast MicroProfile has been moving. The latest release in MicroProfile 6.1 was released in October 2023. Similar to Jakarta EE, MicroProfile also basically supported by major the industry leaders such as IBM, Microsoft, Red Hat, like Fujitsu, Tommy Tribe, and together with other JAX, and plus the Oracle as well, and the Piara. And there's many implementations. So I mentioned earlier, Jakarta EE and MicroProfile, they provide APIs. But for implementations, you will need to use basically one of the implementations support MicroProfile and Jakarta EE. So in this talk, I will choose OpenLiberty because I work on OpenLiberty. So I have the skills in OpenLiberty to demonstrate how easily you can use OpenLiberty to use build cloud native applications using MicroProfile and Jakarta EE APIs. As you can see here, we have a website in the MicroProfile.io compatible. You can see OpenLiberty on the top is support the latest MicroProfile releases. Actually, it's a compatible implementation to release these MicroProfile specs. So I mentioned a lot about OpenLiberty. OpenLiberty is an open source project and by IBM, and also is a great support for MicroProfile and Jakarta EE. So OpenLiberty favors the standard over its own proprietary APIs. So it's a kind of first class support for the MicroProfile and Jakarta EE. And OpenLiberty also provides really basically is user-friendly tools for you to develop your microservices. As you can see here is the roadmap. It has been the first one to support both Jakarta EE10 and MicroProfile 6. Again, the first runtime production ready to support both Jakarta EE10 and MicroProfile 6.1. And basically, is I mentioned earlier, is the vendor neutral APIs got great support by OpenLiberty. Whenever we have some innovation, we would like to contribute to the Jakarta EE or MicroProfile to be standardized. It's not like we put in the OpenLiberty first. If we could don't create in the a standard, we will go there first, and then we provide implementations. So Liberty is one thing I would like to mention. Liberty has a great zero migration. So basically, which is different from others, is if some feature you use in OpenLiberty, you can move to the latest OpenLiberty release, and you do not need to worry about migration. So it's that feature will stay unchanged, and you can benefit from the CVE fixes and also performance update. And also is OpenLiberty is very composable, just enough runtime to support your application. And every 4 weeks it has release, and also have a great developer experience, and Kubernetes optimized. If you know WebSphere, WebSphere is a Java EE implementation. It gives you everything in one big blob. So it will take time to start your application. But once it starts, it's really powerful performance. And however, it's not properly is good for the very lightweight microservices. With that, we have the liberties. Basically, all you get is a kernel. Depending on what kind of feature you need, just give you enough runtime to run that feature. If you change the feature, and then give you different building blocks. So that's kind of how it works. And then Liberty support for both basically is standalone development and also containerized the development environment. It has a great basically is support and structure for the the containerization. All this image you push to the either Docker Hub to both Docker Hub and the IBM Container Registry (ICR). So basically, you have the different Java version and then kernel, and then you do copy the config, and then you run feature.sh. So this line basically give you just enough runtime to run your application. And then you can just copy the apps, and then you run the config.sh, so give you optimization. This is a highlight, zero migration and continuous delivery. So every 4 weeks you have full release, and it has a full circle, give you full circle support from the plan to the day 2 operation. So as you can see, the Liberty give you a really, really rich developer efficiency. So if you do a greenfield development, you just log on to start.openliberty.io, create a project, and then you can do the demo mode and then do the Maven Gradle build, and then it has basically rich framework for the testing, and also it support hot code replacement for debug. And also, if you think about the cloud, and Liberty has Liberty operators for both, basically is for WebSphere Liberty application or the Open Liberty application. As you can see, you don't need to write your Kubernetes. Basically, it's a YAML file and very long. You describe service and the deployment with this operator. Just a few lines. You just need to describe like your Docker image and pull policy, or the specify the storage, and you are done. So it's pretty minimal knowledge needed for write your basic deployment YAML file. And this operator is a level 5 operator, has all the kind of capabilities available to you. And for the cloud, one thing I'm very proud to say, you can find Liberty on the Azure Cloud. We have a great basically collaboration with Microsoft. So you can get basically you can from Azure dashboard marketplace, you can get either Open Liberty or WebSphere Liberty from there. And the same thing for AWS. And for the day 2 operation, and we have basically login metrics, tracing, and health all available to you. For the metrics tracing metrics, we use basically MicroProfile metrics. For tracing, use MicroProfile telemetry, offer you tracing, and health, we use MicroProfile health. So basically, it's to help you with interact with Kubernetes. For tracing is basically it was a bigger switch from MicroProfile open tracing to lately MicroProfile telemetry. And in the future release, we also trying to do the basically the MicroProfile telemetry cover metrics, logs, and tracing as well. As you can see here, the cloud basically is in Open Liberty. We have this API available to you, the standard MicroProfile and Jakarta EE API available to you. And also, we basically spend a lot of time to focus on performance. So basically, the CPU, basically is how to utilize the CPU and memory. So as you know, the Java is different because it has a JVM. It also has a JIT. So you sometimes will notice sometimes you got a CPU spikes or the memory kind of the spikes. So will cause you slow startup or the slow ramp up time. With that, actually, we in the Open Liberty and Power, basically is collaborated with OpenJ9 and Samaru Cloud. Samaru, which is Samaru is IBM, basically is JDK, basically first open source to OpenJ9, and then it's kind of come up with a product called Samaru. Samaru basically repackaged OpenJ9 together with the OpenJDK. So it's we recently released the Samaru Cloud compiler. It can run as a service. So basically, it's kills CPU spike and also memory spike. And then when you start your application, you got flat basically line. And the other thing is that's look after the spikes. And then is we also basically Open Liberty teamed up with OpenJ9. We looked at the build basically startup performance. and we utilize the Linux CRAU technology. So basically, your application can start in milliseconds. So it's improved the performance by 18%. So this is kind of, you still use your traditional JVM. It's nothing to do with GraalVM. So, and you get all the performance without any compromise. So it's with that is kind of smooth instant on, and also together with the Liberty instant on. So give you all this boost. As you can see from the diagram, and the application can start within a few hundred milliseconds. So the next I would like to talk about basically is serverless, because we conquered the basically the problem with the slow startup. With that, with the fast startup, and then we can talk about serverless. Because if you start your application start too slow, is not suitable for serverless, because it takes ages to start, and then serve requests, and take ages to stop, and then it's not worth the effort. So in order to talk about serverless, you need to understand the Knative. So it's basically the Knative is the implementation for the serverless kind of the theory. So Knative has 3 pillars: build, serving, and event. So Knative was basically provide some capabilities for basically to build the application. And in this session, I will talk more about serving. So basically, we can use the Knative to directly to achieve scale to 0. And also Knative has an event model as well, but I'm not going to talk more on that. So it's my demo is basically use some Azure Cloud compiler to reduce basically avoid any CPU and memory spikes for the runtime, and then instant on to basically give you boost in the startup, and use Knative to scale to 0. So as you can see, this screenshot basically is my application can start within 231 milliseconds. So this is the Jakarta EE basically and MicroProfile applications. So as you can see here, can see CDI and also the JSON P and JNDI, and also the MicroProfile config, health, metrics, REST, Jakarta REST, etc. So it's with that, I will jump to the demo here. So this is already, I have this box basically set up. This setup, this is on basically, I create Azure, basically is a cluster. So there's a Azure cluster, and also the Azure basically is the also guide group or setup. So my application is running. Also have a Knative. So at the moment, if you do get port, you can see here is a Smart Cloud compiler is as a service running, and also have a controller basically manager. My application is not running because there's no load, no request. If I do the Knative basically service, as you can see here, my application is working in the background. So if I go back basically to hit this endpoint to basically do a bit request, as you can see here, is you get basically from code and to serving requests straight away. Now, if I go back to here, I can do a get port. So you can see it's running. So here, let me see how long it take to get it started. If we do queue control logs, so here you can see here 218 seconds and getting started and then serve request. If I do now here, because it's I already done with my request, and it will terminate it straight away. It's basically terminating this 2 instances, and very soon basically it will done. So with that, actually, is if I have a quick look at this one. if I do glide, if I do the Knative, config, so you can see is how easy it is. Basically, is the basically directly do the scale to 0 every 10 seconds. So basically, is if 10 seconds without anything, and it will scale to 0, and the stable window is 20 seconds. If I do the basically cat the Kubernetes YAML, so you can see here, like basically is this is kind is open liberty, open liberty, like this is operator open liberty application, and this is the image, and then is the kind of the service load balancer, and this is basically the whole. I don't need to do anything else. So this is enable give you sufficient access to do the instant on. So run with in the security context. So this is enable some root cloud compiler. So it's that's kind of the pretty much. I'm going to show the other thing is I just want to quickly show you the basically the Docker file. So the Docker file here. So basically this is in the ICR. So kernel Java 11 OpenGNA like UBI image, and then I copy the config. I run feature.sh to just get enough runtime to run my application, and then I copy the wall and run config.sh. So basically optimization. So this is the only line how to speed up. So I just run checkpoint.sh after app start. So this is the only one line code. So to get your startup boost, and your application basically is a Jakarta EE or MicroProfile application, and it doesn't need to know anything about like instant on. So with that, I think that's conclude my talk. If you want to learn new things, and please basically learn about Liberty and also try instant on and etc. So there's a useful resources for you to take away. So with that, thank you for listening. Yeah, that's the end on my presentation.
Thanks for watching. Check out this and more at jdconf.com.